Hi guys, welcome back to DeepBlendArt. Today we're covering the Mirror Modifier, not just what it is, but how to really use it. We'll break it down from scratch and then explore how it opens the door to more advanced creative builds. Like the Roman-style temple we're crafting here, all procedurally. It's both a beginner's guide and a creative deep dive. Let's get into it. Alright, let's dive into Blender and explore how we can use the Mirror Modifier to create some seriously cool geometric designs. We're talking about crafting those stunning columns, bases, and that iconic Roman temple facade. This is all about harnessing a super simple modifier to achieve jaw-dropping, non-destructive procedural results. Let's get started. I'll disable the temple for now, clear the scene, and we'll kick things off with a basic cube. Ready to see how we can take this cube to the next level? Let's add a new cube to the scene. Now, if we apply the mirror modifier right away, you'll notice nothing happens. Why? Let's break it down. The mirror modifier's core function is to mirror your model across an axis, duplicating it like a reflection in a mirror. For example, if I set it to the x-axis, it creates a mirrored copy of the model along that axis. The catch? It uses the object's pivot point, its anchor, as the center for mirroring. Since our cube's pivot is dead center, mirroring it just overlaps the copy perfectly, and it looks like nothing changed. So why isn't our cube mirroring? Its pivot point is smack in the middle, and the cube is perfectly symmetrical. Mirroring it across the x-axis just places the copy right on top of itself. Even if we move the cube in object mode, the pivot moves with it, so the mirror still overlaps. Here's the trick. Switch to edit mode and move the mesh itself. Now the pivot stays put and the mesh shifts relative to it. Boom. The mirror modifier kicks in, reflecting the mesh across the x-axis based on that fixed pivot. Any changes you make to the mesh in edit mode, they're mirrored instantly on the other side. This is the simplest way to understand the mirror modifier. It duplicates your mesh symmetrically based on the pivot and the chosen axis. You can mirror across any axis, X, Y, or Z, as long as the mesh is offset from the pivot in that axis. Try it with the Y-axis. If the mesh is centered, nothing changes. Shift it in edit mode and bam, it mirrors. Same with Z. This flexibility is a game changer for creating complex designs with minimal effort. Now let's level up and explore another awesome feature. Bisect. This option is a bit abstract but incredibly powerful once you get the hang of it. When you enable Bisect on, say, the x-axis, it slices your mesh along that axis, keeping only the positive side and discarding the negative side. Then, it mirrors the remaining piece. For example, with our cube, enabling Bisect on x removes everything in the negative x direction, keeps the positive x portion, and mirrors it to create a symmetrical model. Switch to wireframe view and you'll see it clearly. One half is the original and the other is its mirrored counterpart. What if you want the opposite side? Just toggle the flip option under Bisect. Now instead of keeping the positive x portion, it keeps the negative x portion and mirrors that. For instance, with the y-axis, positive y is one side, negative y is the other. Enable Bisect and it keeps positive y. Add flip and it keeps negative y. This is huge for creating intricate geometric shapes. Imagine replacing the cube with a cone, deleting its bottom faces and mirroring it with Bisect. Shift it along x, enable Bisect, and you get a sleek symmetrical design. Flip it and you've got a whole new look. These options let you craft shapes that would take ages to model manually. Let's go back to our cube and explore another way to customize the mirror modifier, the mirror object option. By default, the modifier uses the object's pivot point. But what if we add an empty object like an arrow and set it as the mirror object? Now the mirroring happens around the empty's position, not the cube's pivot. move, or rotate the empty, and the mirror updates dynamically. This gives you insane control, letting you adjust the mirror point procedurally without messing with the mesh itself. It's like having a custom pivot you can tweak on the fly. Want to take it further? Combine the mirror modifier with an array modifier. Let's say we add an array modifier to our cube, offset it slightly and duplicate it a few times. Now mirror that array using the empty as the mirror object. The result? A mind-blowing complex pattern that looks nothing like a simple mirror. Rotate the empty, and the whole setup shifts dynamically. This combo of mirror and array creates designs so intricate no one would guess they started with a basic cube. If you're new to the array modifier, I've got a full tutorial linked both in the description and above the video. Check it out for tons of cool examples. Now let's talk about clipping, a super handy feature. When you're mirroring, sometimes vertices cross the mirror axis, causing overlap or messy geometry. Enable clipping, and Blender snaps those vertices to the mirror plane, preventing them from crossing. For example, move our cube's mesh in edit mode toward the x-axis mirror plane. Without clipping, the vertices pass through, creating overlap. With clipping on, they stick to the plane, keeping your model clean. This is a lifesaver for things like car bodies or symmetrical objects where you need a perfect seam. Pair clipping with the merge option, and it gets even better. Merge welds nearby vertices along the mirror plane, ensuring a seamless connection. Without clipping, vertices might overlap or separate, ruining the model. With clipping and merge, you get a smooth, unified mesh. This is perfect for precise modeling where topology matters. Plus, the mirror modifier can handle UVs and vertex groups, mirroring them symmetrically or flipping UDIM tiles for texturing. These advanced options make it a powerhouse for both modeling and UV workflows. So, we've nailed the basics of Blender and the mirror modifier. Pretty solid foundation, right? Now let's step it up and see how we can build more complex models with this tool. Let's revisit that Roman temple we talked about earlier and break down how we can create it. Truth is, those columns you see, they were sculpted once and then brought to life using the mirror and array modifiers. I'll turn off the multi-resolution modifier to show you the base version. There it is, the raw sculpted column. To give you the full picture, I started with a single column and a base for the steps. For the column's base, I applied a mirror modifier along the axis to shape it symmetrically. Then I used an array modifier with object offset to rotate it 360 degrees, creating that perfect circular arrangement. For the steps, I did the same thing, but here's the twist. I only needed the mirror modifier on the x-axis, no z-axis mirroring required. Check it out. Same deal with the array modifier and object offset to complete the circular layout. Now, if we re-enable the multi-resolution modifier to bring back the sculpted details, you'll see how epic this setup looks. Boom! I pulled off this modeling with just a few modifiers, and you can follow these exact steps to create your own stunning temple design. And there you have it. Starting with the basics of the mirror modifier, we've taken it all the way to building a procedural Roman-style temple. If you're into learning modifiers from the ground up, but also seeing what they're really capable of, check out the full playlist. It's built with that mindset and linked down in the description. Got something cool in mind for Mirror? Drop a comment. I'd love to see where you take it. If you found this helpful, hit like, subscribe, and tap the bell so you won't miss the next one. See you soon.